On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at two examples of finding derivatives using the product rule for differentiation. In a previous video, we did look at the product rule as an introduction where we found the derivative of these two functions right here, the product of these two functions. We did it two different ways. We multiplied the two binomials together and we found the derivative. And then we also looked at it in terms of a product of two functions where we called this one f and this one g. Let me be very clear before we do these two examples here. When you are trying to find the derivative and you have a product of two functions, you cannot take the derivative of this times the derivative of this. To emphasize that even further, let me show you that. So this is a big no-no. I should have mentioned it on this video, but I want to show you anyway. We see the derivative works, or it's the same derivative regardless of what technique we used here. If we try to say this, y prime equals, and we just take the derivative of this, which is just 4x, and then we multiply it by the derivative of this, which is just 1. So we're saying that derivative is 4x, but as you can see, that's nowhere near the actual derivative of this function up here. So you have to be very careful with that, and I see that mistake often when students are taking a calculus course. They'll see some function times another function, their mind will slip and they'll forget, oh, I got to do the product rule. So with that said, what we have here, y equals sine of x times cosine of x, let's call this function f, and let's call this other function cosine of x, let's call it g. And we are doing a product of these two pieces. So therefore, I'm copying over the product rule. This is how you find the derivative when you have a product of two functions. So we have f times g prime as mentioned in a previous video. So for f, we leave f alone and we're going to multiply f by the derivative of g prime. The derivative of cosine of x is negative sine of x. Now we have our plus, and let's copy down g, which is just cosine of x. And then we multiply it by the derivative of f. F is sine of x. The derivative of sine of x is cosine of x. This is our derivative, and if we clean this up a little bit, we get negative sine squared of x. I took the sine times a negative sign, so we have negative sine squared plus cosine squared of x. And we'll just leave it like that for right now. This does not equal 1. This is not a Pythagorean identity. If that had been a positive sine squared, then yes, this would have been a Pythagorean identity. But again, I'm stressing that to you now. We cannot take the derivative of this one and simply multiply it by the derivative of this one to get our derivative for y here. Be careful. That's always going to be the case. That's why you need to know the product rule for differentiation. So here we have a product e to the x times this function here. So we can call this f and we can call this g. Doing the same product rule based on our notation over here, we take f times g prime. That means we leave f alone, e to the x. We multiply it by the derivative of g, which is going to be 2x minus 5. Again, check out the intro videos and the basic differentiation videos here. I'm just doing the power rule where we pull the 2 down and the derivative of negative 5x is negative 5. Those are some of the basic rules of differentiation. And what we have here is f times g prime plus g, let's take our g function now, x squared, leave it alone, minus 5x plus 1, and let's multiply by f prime. The derivative of e to the x is e to the x. That's an easy one to remember, right? Now from here, we could do other things. I'm actually going to show you a few things we could do with this one. Since we have an e to the x in both of these pieces, I want you to focus on this chunk and this chunk. They're separated by that plus right there. We have a common factor actually in those two chunks. If you look at this one and this one, we can factor out a e to the x from both of those pieces. And when we do that, when we factor a e to the x away from this, we have 2x minus 5. When we factor a e to the x out of this, we have plus x squared minus 5x plus 1. That's a weird way of looking at a greatest common factor, but really we can factor out that e to the x from both of these, leaving us with this. And then finally, we can take all this and combine like terms on the inside. We have that x squared. Then we have, what, minus 3x when we combine like terms, 2x minus 5x. And then negative 5 plus 1 is negative 4. Now we can actually factor this even further as well. Y prime equals e to the x. We can factor this right here to be x minus 4 times a x plus 1. I factored this little piece in here. And I'm glad that we ran across this because later on down the road, sooner than what you think, you'll be setting derivatives like this equal to 0. And if we put a derivative in its factored form, it's a lot easier to solve that when it's equal to 0 versus something that looks like that right there. So a good time for us to kind of revisit some factoring techniques that we saw the GCF here, and then we factored this quadratic trinomial to get this. And there you have it. 2 examples of where we use the product rule, and also recapping on why we must know the product rule. There's a big no-no down here. We cannot take the derivative of one function and multiply it by the derivative of the other. That never, ever, ever works. This little product rule right here is what you definitely want to know, and that's exactly what we applied in these 2 examples here. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.